Hello, my name is Brandon, and welcome to the next video in my series on basic statistics. If you are new to the channel, welcome. It is great to have you. If you are a returning viewer, it is great to have you back. If you like the video, please give it a thumbs up, share it with classmates, colleagues, or friends, or anyone else you think might benefit from watching. So now that we are introduced, let's go ahead and get started. So this video is the next in our series on descriptive statistics. In this video, we will focus on IQR, which is the interquartile range, and box plots. So box plots are one of the first techniques you will use to visualize the shape of your data. They are pretty straightforward, relying on only 5 numbers. They become even more powerful when you have multiple groups you want to analyze. So you can do a box plot for each group, put all those box plots on the same graph, and then look across them to look for similarities or differences. But enough talking, let's go ahead and get into it. So what are some uses of box plots? Like I said before, it's a simple way to visualize the shape of your data. So does your data follow a normal distribution or bell curve? Or is your data slanted to one side, which is skewed? A box plot can tell you that. They are easy to interpret. Since it's just a series of boxes and lines, you can easily figure out what it's trying to tell you. We can tell if our data is pulled or skewed in one direction and by how much relative to our other observations. It's an easy way to identify outliers. So do we have extreme values either on the low end or the upper end? A box plot gives us a quantifiable, visible measure for doing so. It makes comparing characteristics of data between categories very easy. So like I said, you can have several groups, do a box plot for each group, line them up side by side, and then scan across to see for any differences or similarities, such as the median or the interquartile range, which we'll talk about in a minute, or any outliers. Now, there are 2 main types of box plots that I have come across in my learning and in my teaching. So we will focus on the most useful, in my opinion, one first, and then we will briefly discuss the second one at the very end. So it's a slight difference, but in my opinion, it's a very big difference and a significant difference when we're talking about the usefulness of box plots. So just be aware that what we do here first might be different than what you see in your textbook, but we will get to both eventually. And finally, also know that box plots are called box and whisker plots. So a box plot and a box and whisker plot are the same thing. Okay, so a brief review of percentiles and quartiles because we need those to do a box plot. So first we take our data and we sort it from smallest to largest in order. So on the left we have our minimum value, on the right we have our maximum value. So for quartiles, we just divide our data up into 4 equal pieces. So the middle is the 50th percentile or the median, which means half our data values are below and half our data values are above that point. Quartiles further divide those into 2 parts. So the 25th percentile, or the first quartile, the first 25% of our data is in the first square, the second 25% in the second square, so on and so forth. And then the 75th percentile is called the third quartile. Now in the middle, between the 25th percentile, or the first quartile, and the 75th percentile, or the third quartile, is called the IQR, or the interquartile range. So it's simply the middle 50% of our data. So here's our IQR and our median, 25th percentile or Q1 on the left, 75th percentile or Q3 on the right. Now I will note that this visual shows the median or the 50th percentile exactly in the middle of the IQR. Now that rarely ever happens, so we're just doing this for teaching purposes. But the median will actually slide around inside the IQR, and that's very important, because that tells you characteristics about the distribution of your data. So what we do to find that is we take all our data values up to the third quartile, and then we chop off the first quartile, and that gives us our interquartile range or IQR. So the IQR is just Q3 minus Q1, and that gives us our middle 50% of the data. So here is our IQR. The next thing we need to discuss are potential outliers in our data. So what we will do is we will extend temporarily whiskers on each end of our IQR. So here is what's called our lower limit, and over here what is called our upper limit. So the lower limit and upper limit have a mathematical definition, and that is 1.5 times the interquartile range, or the IQR. So we take whatever distance the IQR is, from the first quartile to the third, multiply that by 1.5, and that is our upper and lower limit for outliers. So any value beyond that is going to be considered an outlier. That's our outlier zone. So the lower limit and the upper limit we discussed in the previous slide are kind of the theoretical whiskers we're going to work with for now. However, they will usually not end up there. And here is why. Let's say that our minimum value of our entire data set falls where this circle is. Now, why would we have a whisker that goes further to the left than our minimum data point? That would not make any sense. We don't have any data down there. So what we would do is drop that down and then move the end of our whisker over, and then that becomes our left whisker, or our lower whisker. Now the same would hold true on the right. So if we had a maximum value that fell between the third quartile and the upper limit, we would move the whisker to the left and shorten it as well. So this is a graphic of a full modified box plot. We put everything together from their previous slides. Now this is called a modified box plot versus a traditional box plot, which we'll talk about in the very last slide of the video. So we have our IQ there in the middle. That's the middle 50% of our data. We have our lower limit and upper limit, which theoretically is 1.5 times the IQR. And then anything beyond those boundaries are considered outliers. Now I will point out here that this is an ideal. This is sort of a model. But this is what a box plot would look like if our data was perfectly symmetrical. So we can see that the median is right in the middle of the IQR, our lower limit and upper limit are the same length, and so on and so forth. So you'll rarely see a box plot that looks this perfect, but I wanted to give you a model of what's going on underneath everything you're going to learn later. But this begs the question. We've talked about the lower limit and the upper limit, but we haven't talked about how to actually find them, and that's what we're going to do next. So finding the IQR and the limits. So here is our IQR. We can see that our first quartile falls at 56,900. Our third quartile falls at 93,825. And remember from previous videos that this is fake salary data that I created. So those are actually dollar values. So to find the IQR, we simply do subtraction. It's Q3 minus Q1. So in this case, 93,825 minus 56,900. And then we have an IQR of 36,925. Okay, so now we can use that to find our lower and upper whiskers, and this is where you have to be careful, so please pay attention. So the lower whisker and upper whisker are going to be determined either theoretically by our 1.5 times the IQR or other values in our data set, more than likely the latter. So the IQR is 36,925. The lower limit theoretically would be Q1 minus 1.5 times the IQR. So that equals 56,900 minus 1.5 times 36,925, which gives us a theoretical lower limit of $1,512.50. And anything below that will be considered an outlier. But look at our data. Our lowest value is 29,500. So that's going to be our lower whisker value. Even though our lower limit theoretically is 1,512.50, we're going to use our minimum data value, and that will be the lower boundary. The upper limit, Q3 plus 1.5 times IQR, is 93,825. You can see that there, plus 1.5 times our IQR. That gives us a value of 149,212.5. Now, if you notice, this is a bit different. So 149,212 actually falls in between two values in our data set, between the 11th and 12th value. So this will be a little bit different. In this case, our upper whisker moves back to the previous value. The upper whisker becomes the next highest value in our data set. So in this case, it would be 99,200, because 149,212.5 falls between the 11th and 12th observation. So the upper whisker backs up to the 11th, and that will be where that falls. So here is our actual box plot from our data. So here in the middle is our IQR, and then up above are our theoretical upper and lower limits, which are denoted by the dashed lines down here in the lower left by our box plot. Now, as discussed, our minimum value in our dataset is 29,500, so that's going to be our lower whisker. There is no point in going all the way down to 1,500 when there's no data there. For our upper whisker, we move down to the next highest observation. So in that case, the upper whisker will be 99,200. So what we have done is taken those theoretical limits and moved them in towards the proper values in our dataset. And of course, we cannot forget our outlier out here, someone making $500,000. Wouldn't that be nice? And of course, it's an outlier because it is above 149,212.5, not because it's above 99,200. So we always have to keep that in mind. So as I mentioned at the very beginning, box plots become very powerful when you put them side by side with one another. It allows you to do easy comparisons. So the time to insight is very fast. So here we have simulated salary data for 3 cities: Atlanta, Cincinnati, and San Francisco. Now the first thing you will notice is that these box plots are not horizontal, they are vertical. And there's literally no difference between a horizontal and a vertical box plot. The minimum value is down here at the bottom, and the maximum values are towards the top. We just stand it on end. So we have Q2, which are a median, that's the line in the middle of our box. We have Q1 and Q3, like always. And then we have our upper limit and lower limit, which in this case are our upper and lower whiskers. And in each city here, we have one outlier, which is represented by the dots. Now the power here is in comparisons looking across. So first let's compare the median for each city. In Atlanta, the median is about $75,000. In Cincinnati, it's pretty close, maybe a little bit lower. But in San Francisco, you can see that it's much higher. It's probably around $80,000, $85,000. So of course, that tells us that the middle salary, the middle value, is much higher in San Francisco. Now let's look at the interquartile range for each city individually and then across the groups. So if you look at Atlanta, the median is pretty much right in the middle of its interquartile range. So that tells us that the salaries are evenly distributed on both sides of the median. In Cincinnati, you will notice that the median is a bit lower. So the top half of that box from the median to Q3 is a bit longer than the first half of the box from Q1 to the median. So that tells us that the salaries tend to be higher. It's pulling that part of the box plot upward in the graph. And then in San Francisco, you can see that effect pronounced quite a lot. So you can see that the upper half of the interquartile range is really, really stretched out. And the reason it's stretched out is because of their higher salaries in the upper end of the distribution that's pulling our box plot upward. Next, let's look at the lower limit or lower whisker of each. In this case, pretty much the lower whisker is set at the minimum salary in each city. Because 1.5 times the interquartile range is actually pretty far, so in this case, it defaults to the minimum salary. Next, let's look at the upper limit for each city. So remember that 1.5 times the interquartile range is the boundary by which we denote an outlier. So we know that each dot in each city is further than 1.5 times the interquartile range. What we also can tell is that where the whisker stops in the upper limit, the upper whisker, that is the next highest salary in the data set for each city. So in Atlanta, we have a salary of $175,000 approximately. That is the outlier. Then the next highest salary is at the edge of that upper limit or the upper whisker, which is about $120,000. For Cincinnati, the outlier is about $155,000. And then the next highest salary is about the same as Atlanta, which is about $120,000. In San Francisco, the outlier is almost $400,000. And then the next highest value is around $200,000. So finally, if we step back and look at everything at once, what can we figure out from these box plots? First of all, we can tell that San Francisco has much higher salaries compared to Atlanta and Cincinnati, at least in this sample. We can also tell that there is more salary variability in San Francisco. As we can see, everything is stretched out. So yes, the median is higher, but the distance from Q1 to the median and the median to Q3 is also stretched out. And then the whiskers are also stretched out beyond that. So we know that San Francisco has more salary variability compared to Cincinnati and Atlanta. So again, side-by-side box plots with multiple categories or groups can tell you a lot. So finally, here is what a traditional box plot is. Everything else is the same, except for the whisker boundaries are just the minimum and maximum value of the data set. So we would call this the 5-number summary box plot. It's based on the 5-number summary, which is the minimum, first quartile, median, third quartile, maximum. Now, a limitation of this type of box plot is that there's no mechanism for identifying outliers. Since we define the whiskers as the minimum and maximum, it's going to encompass the entire data set no matter what. Okay, so that wraps up this video on IQR and box plots. So box plots are deceptively simple. However, they can tell us a lot of information about our data, how it's shaped, where its median is, and where outliers might be. And they become even more powerful when you put them side by side with each other for different groups. So I highly recommend one of the first steps you do when you're analyzing data is to do a box plot for each category that has a quantitative measure and take a look at it and make any comparisons if those comparisons make sense. And lastly, thank you very much for watching. I really appreciate you taking your time to sit and learn with me, and I look forward to seeing you again next time. Take care.